Macros are a way to add new programming constructs to a Lisp, like Clojure. So they're code that generates other code at read time. Now remember that normally the reader parses our code and then sends the forms to evaluators for evaluation. With a macro, an additional step happens. The macro is expanded and some values inside the macro are replaced before the whole thing is sent to the evaluator. This is somewhat similar to what happens when we have a templated type in C++. Right, so here we have a vector class, and it's going to replace all occurrences of this type T with int inside the vector class. Then the compiler is going to compile a brand new version of the vector class with ints instead of the value T. And similarly here, when we have a vector of strings, again, all the references to this generic type T inside the vector class will be replaced with string, and the compiler will recompile a new version of the vector that holds just strings. Okay, function calls always result in the parameters being evaluated. Okay, so let's look at this function. It's called actOnWaterState. It takes a temperature and then something to do based on the state of the water. So if it's frozen, we're going to do this. If it's water, we're going to do this. If it's steam, we're going to do that. Okay, so we have this condition that we're checking the temp, and you might think this would work. So this looks like it's saying if the temp is less than or equal to 32, we're going to execute this code, the if frozen do, and so on. Okay, but if I were to run this, let's see what happens. So we're passing in 20 first. So 20, you'd think we'd only see print ice, right? You'd think that we wouldn't see print water or print steam. But clearly we did. We saw ice, water, and steam. Let me comment out that one and run this one. Again, 200, we'd think we'd see water. Okay, but we see all of them, ice, water, and steam. And then lastly, if we pass in 2000, again, we'd think we'd see just steam, not the ice or water. Okay, but we see all of them. So the problem with this code is that the parameters that are being passed into the function are always evaluated by the evaluator before the function is called. So try and remember back to that picture I drew of recursive evaluation very early on in the Clojure lectures. Right? Evaluators spawn sub-evaluators and so on. Okay, what this means is that the print lines are being evaluated before the flow of control even reaches the code inside the function. So something that looks like this, right, this call here, actually turns into something that looks like this. Okay, because each print line is evaluated when the function is called. And when those functions are called, the three prints show up on the screen. Now, print line always returns nil, so that's what's actually getting passed into the function. So when we do something like this, actOnWaterState with 20, and then we have these three function calls, right? The function calls are happening before the flow of control even jumps into the function, and each one of these returns a nil. So really our function call looks more like this. Okay, so this is where macros come in. A macro allows you to control what gets evaluated and when. So here we would like to delay the evaluation of the parameters until the flow of control is inside the function call. A macro is like a function, but the programmer decides when the arguments are evaluated. The reader generates a new function based on those arguments, and then it sends the whole result to be evaluated. Okay, so this code builds a macro. So notice the def macro. It's going to be called actOnWaterState, and it looks like a function, right? Because it has this parameter list. We have the temperature, and then the if frozen do, if water do, if steam do. Now inside a macro we have these special symbols, a backtick. Okay, the backtick says not to evaluate this code yet. Okay, we'll use the backtick in a second here. The tilde means to unquote or replace some code with a passed-in parameter. Okay, so this says we actually want to replace something inside the code. The temp with a pound sign here is used to generate a unique binding name. So since the parameters hold unevaluated code, we could have naming conflicts between them and the macro code. So all this temp pound sign says is basically create a unique name, something that's guaranteed to be unique. Okay, so let's look at the contents of the macro. This says, the backtick says, don't evaluate this code yet. Okay. The first thing we're going to do is create this local variable called temp, right? And Clojure is going to make sure that this actually gets turned into something that's guaranteed to be unique. Okay, and here we have the tilde. This says we're going to replace this code with a passed-in parameter. Okay. Then we have a condition where we're saying if the temperature is less than or equal to 32, again, this is going to be replaced with something that's actually passed in here. If it's water, if it's steam. Okay. So now when we call the macro, so the call to the macro looks very similar to like a function call. I'm going to pass in 20, the result of multiplying 20 times 10, and the result of multiplying 20 times 100. Okay, and what we're seeing here, ice, this is the result of the first call. Let me comment out the other two just to prove this. Okay, we should just see ice. Okay, so what's happening here, because this is a macro, we're basically saying we want this function call to happen in two steps. First, we want to generate a new function, and then we're going to have that function be evaluated. Okay, so the parameters to the macro are 20, this bit of code here, this bit of code here, and here. Okay, and again, the backtick says let's not run this code yet. Right? We're just trying to replace some things like the temperature and the if frozen do, if water do, if steam do, and then after all those things have been replaced, then we're going to send that result to be evaluated. Let me run the other ones. Okay, I didn't put a hard-coded value of 200 here because I wanted to show you that this value for the temp, it really should not be evaluated until the new function is generated. Okay, so you should kind of prove to yourself that that multiplication is not happening right away because it's a macro. That multiplication is being delayed until the function is actually being evaluated. And then lastly, the steam. Okay, so this whole idea of creating a function from a macro is kind of interesting. What is going to be created is something that looks like this. So the act on water state macro, when we pass it 20 and these three prints, the macro is going to expand into something that looks like this. Okay, this looks like a function called act on water state that takes a temperature. We're going to let the temperature be equal to that value 20. Then we have the conditions, and we're basically plugging in what should happen in each one of these cases. Now you can see how the macro will actually expand using this thing called a macro expand function. Okay, so I'm going to call macro expand 1, and I'm going to basically pass in this bit of code to see what does this actually get expanded to. Okay, so the print put it all on one line. This is the exact same output. You'll see it's creating a let. That temp # basically got turned into this name. So this is guaranteed to be unique. It holds the value 20. Then we have a condition. Here's just the fully qualified name for the functions we're calling, less than or equal to, less than temp, less than or equal to 32, temp less than 212, else print steam. So the macro expand function allows you to see what actually gets, what the macro actually expands into. And that's sometimes useful to just verify that your macro is correct. Okay, incidentally, this is how logical AND and OR with short circuit evaluation work. Remember with the AND, the first operand, if the first operand is false, then the second one should not even be evaluated. And similarly with the OR, if the first operand is true, then the second operand should not even be evaluated. In Clojure, we need a macro to do this. We need a macro to delay the evaluation and possibly not even evaluate the second parameters or the second operands if the first one is either true or false. Okay, so macros allow us to kind of add to the language itself. We can write these things that look like functions, but we can replace certain parts of the functions with other things.